Alright, so here's my little setup that I'm using. So I'm just making a change to this chassis right now. I decided I wanted these slots to be slightly larger, so I've got to hog them out and then rechamfer them, and then the other operations on the other side, but there's more that I'm going to do with that, so I'm not doing that yet. So here we go. So the whole thing starts with me clamping it into this fixture. I just use these 3D printed toe clamps that I made and clamp them down with this little guy, and it's got the torque chuck, so pretty easy to do. And to get that lined up, I've got these little toe reference point things that stick in here in the slot. I just put those on all four corners before I tighten these down, and then I take them back out. And now we're ready to probe this in. So I'll show you the probe routine that I do. So here I've got part-specific probe macros that I wrote. This one is for chassis revision 1 top. So we're going to run that. First it moves over the probe. It's getting ready for me to load it, and it stops so that I can position the spindle, just so that I know it's always in the same position. Helps with repeatability. Then I press go down here on my pendant. And it picks up the probe. It's just a friction fit. And then I take the USB cord and I plug that in like that. And then I press go again. It measures the tool length offset. And then it will start the probe of the actual chassis. So I have this point defined where it goes down and then starts to probe this feature. So it's finding the center of this pocket. And then it will find the Z height. And it will store that as the WCS 0 for G54. And now it's waiting for me to unload the probe, so I unplug it, and the wire just tucks back in here, just like this, and I stick it in that little slot next to where I've got my dial indicator stored, and then just pull that guy out of there. It's hard to do with one hand. Normally I'd use two hands, and then stick it back where it goes, and then I hit go again just to finish out the probe. And now we're ready to cut. So now I will take the front cover and put it on. It just sits there like that. And now I go into my G-code folder, and it's the only one in there so I don't get confused. And I press run, and it starts to go. It does all the tool change magic. Kind of hard to see, but measures the tool. And this is just a 3/16 single flute end mill. It goes over here and picks up the dust shoe. This is so I don't have to clean up any metal chips. Works pretty well. I have this set to use compressor as well as vacuum. Comes over here and cuts these features. Unloads the tool. Goes and picks up the chamfer tool. Measures that. And picks up the dust shoe. And now it's gonna start cutting the chamfers. Done. So it's just going to put away the dust shoe. Oh, by the way, it's my little air compressor that does the air blast. And my cyclone separator and little dust collector setup all fits under the table, nice and tidy. So yeah, that's that. And there we go. All nice and clean. And that's the only mess that it leaves. Just a little bit of stuff that it doesn't vacuum up. So I've got 3 more of these to go, and then got another thing that I'm doing on the back, which it's hard to visualize without seeing it, but basically the rear of these takes a beating on the track and gets worn down. So I've designed a titanium skid plate that recesses into this, and of course has matching chamfers for all the holes and everything. So it's going to be 1 millimeter thick, and I'll just recess, I'll cut a pocket there for it to fit in, and it'll be nice and smooth on the bottom, but the back will be titanium, so grade 5 titanium, so pretty tough stuff. Hopefully that will make these last longer, because that was the one thing I was disappointed by after I ran at the Adam Drake gas truck races. I definitely had a lot more wear on the back of the chassis than I wanted.